This is a quick video about how to multiply with lines, and it's dedicated to Mrs. U. So usually if we have a problem like 12 times 13, we'll solve it using a normal algorithm. And when I do it this way, I find that my product is 156. Now, what if there's another way that we can solve this without using any numbers at all? In this method, we're just going to draw a couple lines. So I'm going to start with one vertical line, which represents my 10, and then two vertical lines, which represent my two ones. And that's my 12. Now I'm going to do another horizontal line up at the top, which represents 1 10 from my 13, and three horizontal lines a little bit lower down to represent three ones from the 13. And when I look at it, I have 1 10 and 2 ones multiplied by one more 10 and 3 ones. Now at this first intersection here, what I'm really saying is 10 times 10, because I have a vertical 10 and a horizontal 10. So I know that's going to be in hundreds. And for this intersection, it's going to be 10s times 1s, as is this intersection here, 10s times 1s. Because any time you have 1 times 10, it's going to be a certain number of 10s. And at this bottom right grouping, we will have 1s times 1s. So if I use that information, I can quickly count the intersections to know my product. Okay. Starting with our 10s, we have 10 times 10, which is 100. We can look at our 10s times 1s, and we have 1, 2, 3, 4, 5 of those, so we have 50. And then we have 1s times 1s, and we have 6 of those. And if we add our 100 plus 50 and 6, we have 156, which is the same product as when we solved the regular algorithm. If you wanted to look at it a little bit differently, you can look at your 10s times 10s, which is 100, plus 2 10s, which is 20, which is 120, which is your number on the bottom here. And we have 3 10s, which is 30, plus 6 1s, which is 36. So it groups identically once again. And there you have how to multiply with different lines. Now you can add sections if you want. You can draw another line if you want to get into thousands or 10,000s. Remember that each additional line is a multiple of 10. So this really is another way of looking at the base 10 system.